Welcome. In this video I'm going to show you how you can obtain the effect size measure phi with Python. I'm currently using Jupyter Lab with a kernel of Python version 3.8, but I think it also works with 3.12. Um, this is an effect size measure that could be used after a goodness of fit test. It actually takes the chi-square test value of the test, and so the statistic, and divides it over the maximum possible effect size, and then takes the square root out of that. Unfortunately, there are no rules of thumb for it, but you can convert it to Cohen's W, and for that there are some rules of thumb that you could use, unless you're not allowed to use something like that. To show you how this can be obtained, I'll need some example data, so I'll load in pandas, so I can load the general social survey data from 2012, adjusted for some example purposes. I actually don't need all the data, I just need one nominal field, so I'm going to be using as a nominal field mar1, which is the marital status. So I'm going to save that as nominal field, and to give you a quick impression, the value counts as frequencies. So 79 people indicated they were separated. In another video I show you that I actually have my own library that has this function for you, so you can just straight away use it. But in this video I'll be going over the formula. So looking at this formula, we'll need the total sample size, n, so that's simply the sum of those frequencies we found earlier. I'm going to assume that each category had the same probability, the same expected proportion. So I'm going to first have a look at how many categories there were. So that's the number of categories and number of frequencies I simply have. And then I'm going to say 1 over k, that's going to be the proportion for each category. So I multiply it by the number of categories. So it's going to be a list with 0.2, in this case, 5 times. The next thing is we need the minimum of the expected proportions, but in this case they're all the same, so it doesn't really matter which one I take, but I can use the min function just in case you have your own specified expected proportions. Now we need the chi-square value. I have separate videos on how this can actually be calculated. But in this case I'm just going to use this formula, which is going to be the observed proportion, so the frequencies divided by the sample size minus the expected proportion, so that's being done over here. That needs to be squared, so we square all of that, and then we divide it by the expected proportion. We sum all of that up, that's that big looking E over here, and we multiply that with the total sample size, so that's over there, so that should give us a chi-square value. So let's say this is our chi-square value. We can now fill out the original function formula from phi, so this one. We have that chi-square value, we have the sample size, we can do 1 over and then the minimum expected count minus 1. So it's a matter of filling out the formula and you should be done. In this case 0.40. You could convert this now to Cohen's W if you like, and then obtain some rule of thumb for this, but this is how you can obtain phi. Alright, I hope this video was helpful and thank you for watching.